Welcome to the chapter on the basics of electricity. In this chapter, we will cover units and measurements, electric current, voltage, resistance, and Ohm's law. These basic concepts are crucial for analyzing and designing electrical circuits. In electrical engineering, we use the International System of Units to measure various electrical quantities. Charge is measured in coulombs, current in amperes, voltage in volts, resistance in ohms, and power in watts. Understanding these units is crucial for analyzing and designing electrical circuits. Electric current is the flow of electric charge through a conductor. It is measured in amperes, where 1 ampere is equal to 1 coulomb of charge passing through a point in 1 second. The formula for current is I equals Q divided by T, where I is the current in amperes, Q is the charge in coulombs, and T is the time in seconds. For example, if 10 coulombs of charge pass through a wire in 2 seconds, the current is calculated as I equals 10 coulombs divided by 2 seconds, which equals 5 amperes. Voltage, also known as electric potential difference, is the energy per unit charge. It is the force that pushes electric charges through a conductor. Voltage is measured in volts. The formula for voltage is V equals W divided by Q, where V is the voltage in volts, W is the work done or energy in joules, and Q is the charge in coulombs. For example, if 20 joules of energy are used to move 4 coulombs of charge, the voltage is calculated as V equals 20 joules divided by 4 coulombs, which equals 5 volts. Resistance is a measure of the opposition to the flow of current in a conductor. It is measured in ohms. The resistance of a conductor depends on its material, length, and cross-sectional area. The formula for resistance is R equals rho times L divided by A, where R is the resistance in ohms, rho is the resistivity of the material in ohm meters, L is the length of the conductor in meters, and A is the cross-sectional area in square meters. For example, a copper wire with a resistivity of 1.68 times 10 to the power of negative 8 ohm meters, a length of 2 meters, and a cross-sectional area of 1 times 10 to the power of negative 6 square meters, has a resistance calculated as R equals 1.68 times 10 to the power of negative 8 ohm meters times 2 meters divided by 1 times 10 to the power of negative 6 square meters, which equals 0.0336 ohms. Ohm's law is a fundamental principle in electrical engineering that relates voltage, current, and resistance in a linear circuit. It states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points and inversely proportional to the resistance between them. The formula for Ohm's law is V equals I times R, where V is the voltage in volts, I is the current in amperes, and R is the resistance in ohms. For example, if a resistor with a resistance of 10 ohms has a current of 2 amperes flowing through it, the voltage across the resistor is calculated as V equals 2 amperes times 10 ohms, which equals 20 volts. In summary, we covered the basic units and measurements in electrical engineering, the concept of electric current, voltage, resistance, and the fundamental principle of Ohm's law. Understanding these concepts is crucial for analyzing and designing electrical circuits.